Definition: integers a and b are said to be relatively prime if and only if their greatest common divisor is 1. In 20 and 21, trace the action of algorithm 4.10.2 to determine whether the integers are relatively prime, 34,391 and 6,728. So here's the algorithm. We start by writing the variables in this algorithm. In this case, my inputs are a and b, where capital A is bigger than capital B. So these two numbers are my inputs, and the bigger number has to be capital A. Now, these are capital letters, which are supposed to represent global variables, meaning that these numbers never change in the entire program. Okay, so let's go through this program. Lowercase a is defined as capital A, lowercase b is defined as capital B, and lowercase r is defined as capital B. Since b is non-zero, we enter the while loop. R is a mod b. Now, if you need help figuring out how to find this number, it's 751. You can watch the last video and see how we did the division algorithm to compute a mod b. A mod b is 751. A is going to be defined as b, and b is going to be defined as r. Since b is still non-zero, we redefine r to be a mod b, which is 6,728 mod 751, which is 720. Next, we redefine a as b, which is 751, and we redefine b as r, which is 720. Next, r is a mod b, which is 31. A is going to be 720, and b is going to be r, which is 31. Next, r is a mod b, which is 7. A is going to be 31, and b is going to be r. Since b is still non-zero, we keep going through this loop. R is a mod b, which is 3. A is going to be 7. B is going to be r, which is still non-zero. So r is a mod b. A mod b is 1. A is b, and b is r. B is still non-zero, which means r is a mod b, which is 0. A is going to be 1, and b is going to be r. Now, b is 0, which means we could finally exit the while loop, and GCD is going to be defined as a, which is 1. And that's my final answer. Therefore, these two numbers are relatively prime because the greatest common divisor is 1. Thanks, everyone, and I'll see you in the next video.